All right, so this is getting into our unit on factoring. So what you did last week with the FOIL, so we multiplied, right? You turned this into me, which they look very good. So you did excellent on this. So now what we're doing is, instead of starting with two parentheses and getting this, what we call a trinomial, we are now doing the reverse. I'm giving you the trinomial, and then you're going to come up with parentheses. But we're going to kind of do it in, there's 4 different methods that we're going to look at for factoring. Okay, so you have a packet. I'm going to break this up into multiple videos so you can just follow along, just going to next video. All right, so factoring is the reverse of multiplication. When asked to factor a polynomial, we want to find out what polynomials were multiplied together to get the one that we have. We are breaking the polynomial down into its factors. Okay, so think about if I have like 3 times 4 and that equals 12. We took the number 12 and we broke it down into its factors, right? So 2 numbers that multiply together to give you that. So now we're just looking at if we have a polynomial, so we have like letters and exponents and stuff like that. How did I get to this? What 2 things did I multiply together to get this? And that's what we're looking at. All right, so our first method is called the greatest common factor. So remember with greatest common factor that a factor, which you also have this paper, this yellow paper, these are all the factors for every number from 1 to 100. So basically factors are, if we look at 25, factors of 25 are 1, 25, and 5. For 35, it's 1, 35, 5, and 7. These are all factors of 35 because these numbers multiply together to give us 35. Okay, so when we talk about factors, we're talking about these numbers, and you absolutely can use this. And the students use this on the quiz actually as well. So you're going to have access to this. So when we're talking about the greatest common factor, so if I ask for the greatest common factor between 6 and 16, so I'm looking at these 2 numbers right here, and I'm looking at the list of factors that are underneath, and I'm trying to find the biggest number that they have in common. Now, every number has 1 in common, right? So we don't really consider that when we're looking at our GCF. So I have 1, 6, 2, and 3. If I look here, I have a 2 here, and I have a 2 here. There's no 6 down here, there's no 3 down here, so 2 would be my greatest common factor, which is your GCF. So when we're looking for the GCF, we're looking at what do the terms have in common, okay? So when we look at this down here, right, so we're finding the GCF. So if we are given this, I'm looking at the 2 terms, right, because terms are separated by a plus or a minus sign, okay? So we have 2 terms here, so I'm looking at what do these 2 terms have in common. So we start with our number. So you can use this list or you may know them. So I'm looking at 5 and I'm looking at 20. And I'm trying to find the biggest number they have in common. And if you notice, it's going to be 5. So then I'm going to bring out a 5. And then this has an x, but this does not have an x. So I can't take the x out. There's no letter, no variable I can take out. So when I say take out, we're dividing it out. So so if I took 5 out, so I started with 5, I took 5 out. So 5 divided by 5 leaves me with 1, and then we have x. Now, if you didn't write the 1 and you just wrote it as x, that's fine too. And then I take 20 divided by 5, and that gives me 4. There was a plus sign, so we would just put a plus. So this, I can factor it to 5 times x plus 4. And if you think about it, this is just a reverse of distributive property. So if I were to distribute this, right, this would be 5x, which is that, and then 5 times 4 is 20, which is that. So we're just undoing or doing the opposite of distributive property. If we look at these 2 terms, 2 and 3, they do not have a common factor, so there's no number that's going to come out. However, I notice this has an x and this has an x. So this one has 3, this one only has 1. So how many x's do they have in common? Or they each have at least how many x's? So they each have at least 1 x. This one has 3, this one has 1, but they both have at least 1 x. So I'm going to factor out an x. So this leaves me with 2x. I'm sorry, let's look at this. So it leaves me with 2 because I didn't take a number out. I started with 3 x's, I took one of them out, so now I have x squared. Then we have 3, we didn't do anything with numbers. I had 1x, I took 1x out, so I don't have any x's left. So now again, if I were to distribute this, I would then get to 2x to the third plus 3x. All right, and we look down here, we have 4, 8, and 12. So we're looking again, you can use your yellow paper, looking at 4, 8, and 12, what number was the biggest number they have in common? All right, and that's gonna be 4. So I'm gonna pull out a 4. Now I look at, letters. I have XY, XY, and X. They all have at least an X. These two have Y, but this one doesn't, so I can't take out a Y. This has 1X, this has 2, so they have at least, each one of these terms has at least 1x, so I can pull out an x. So now I'm going to divide, do my numbers. So 4 divided by 4 leaves me with 1. I had 1x, I took 1x out, so that's gone. So all I'm left with is y. And then minus, so 8 divided by 4 gives me 2. We had 2 x's, I took 1 out, so I have 1 left. We have y, we didn't take any y's out, so y is just gonna stay. Plus 12 divided by 4 is 3. I had 3 x's, oh I'm sorry, this one had 3 x's. They still all have at least 1 x. So this had 3 x's, I took 1 out, so now I have 2 x's left. And again, you can double check your work by taking this and distributing it. So 4x times y is going to give me 4xy. 4x times 2 is times negative 2 is negative 8. X times x is x squared, and then we just have a y. 4 times 3 is 12. I have an x and x squared. That becomes 3x cubed. So we know we did it correctly. Here, we can all divide those by 5. I have xy, xy, and xy. They all have x and y. This has 2 x's, this has 1, this has 2, so they all have at least 1 x. If you notice, when we're looking at that, you're trying to figure out how many they have in common, how many x's they have in common, for instance. I always look at the smallest exponent. That's going to be what I'm going to pull out here, is always going to be the smallest exponent. And then this has y squared, and y. So 2, 2, and 1 for exponent. So I'm taking the smallest exponent, so it's just y. All right, and then 5 divided by 5 is just 1. I had 2 x's, I took 1 out, so I have 1 left. I have 2 y's, I took 1 y out, so I have 1 left. Here, 10 divided by 5 is 2. I had 1x, I took 1x out. We had 2 y's, I took 1 out, so then I just have a y. 15 divided by 5 is 3. I had 2 x's, I took 1 out. I had 1 y, I took 1 y out, so there's no more y's. So then this is your answer. All right, so GCF is literally just taking out what they have in common. So trying to find what they have in common. All right, so if we look back here, all right, so then, so it says, keep in mind that the GCF could be negative. And so if the leading coefficient, if the first term is negative, we always pull out the negative out of our GCF. So we always take out, so since this is negative, so I have a squared, 3a, and 9. They don't have, so this is 1, 3, and 9. They don't have any GCF. These two have an a and this one does not. So there's really nothing I can factor out except for, since the first term is negative, I'm actually going to factor out a -1 because we like to pull the negative out instead of leaving it in. So then all that does is -1 divided by -1 would give me a +1. And then I didn't bring any a's out, so I'm just going to leave my a alone. 3 divided by -1 gives me a -3a. -9 divided by -1 becomes a positive. So we always want to factor out the negative if it comes first. So here, if I look here, I have a -6. So I know I'm pulling out a negative. So I have 6, 3, and 12. So I can pull out a 3. So I'm pulling out -3 because my first term is negative. First term negative, negative comes out. mn, mn, mn. So I have m to the third, m squared, and just m. So again, we take the lowest exponent, n squared, n, and n. So lowest exponent is just 1, so that would be n. So now negative 6 divided by negative 3 becomes a 2. I had 3 m's, I took 1 out, so I have m squared. I had 2 n's, I took 1 out, now I have n. Negative 3 divided by negative 3 becomes a positive 1. I had 2 m's, I took 1 m out, so now I just have m. 1 n, I took 1 n out, so I don't have any left. 12 divided by negative 3 is negative 4. I had 1 m, I took 1 m out, so I don't have any left. I have 1 n, I took 1 n out, I don't have any left. So then that is what it looks like. Okay? Now, we'll get into this in the next video. I'll get into the grouping and we'll look at some more. So what I want you to do is in your packet of stuff that you got, so right here, these numbers 1 through 6 are factoring by GCF. So after watching this video, I want you to attempt numbers 1 through 6 in this packet. If you have questions, please feel free to contact me. Thanks.